Good morning, everybody. I hope you're having a great day. We have a Code Forces round today. This is Global Round 23. We also have some changes. First of all, there's the elephant in the room, which is this microphone. It voted Republican. That's why it's an elephant. No, I'm just kidding. But, yeah, we do have a new microphone. Why do we have a new microphone? For better audio quality, right? I have a fan right here, and I like to keep it on because it prevents my apartment and like the room that I'm in from just massively overheating. So I'd like that, and the only way to not have that totally destroy the sound quality is to have a microphone that like only picks up things close to it. And the unfortunate side effect is that means it's got to be in the frame. So we are going to have to live with this at least until it gets cooler, at which point if we want we can switch back, but if people think that it actually is higher sound quality we can keep it. Next thing, we have a new keyboard, we have a new mouse, and all of this is because we have a new computer. That's right, we've got a Mac. Here you go. So, yeah, we're trying out a Mac here, and because we're trying out a Mac, we're no longer using Eclipse. We're using VS Code. That's because Eclipse doesn't work at all on a Mac. It, is super bad, so we're using VS Code, but we're still using Java. Sorry to spoil it for people. Although, I guess the side effect, though, is this does make it a lot easier to switch to C++ if we ever need to. All right, global round starts in 20 seconds. All right, here we go. Good luck, have fun. Let's jump into the contest. Try and win a t-shirt. Top 31 t-shirts. You have an array A of size n of only zeros and ones and an integer k. In one operation, you can do the following. Select two consecutive elements in A, replace them with their minimum. Okay. This decreases the size by 1. Select k consecutive elements and replace them with their maximum by k minus 1. Can you turn this into just 1 after some number of operations? So if they're all zeros, the answer is no. If there's a 1 and you can do...
Yeah, so I kind of got this just completely wrong. I'm trying a solution here that's just not true. If there's a 1, you can just always do it. You just keep deleting zeros, and then at the end you merge k things, and that's your last operation.
All right, we'll try it.
But I don't realize that for 30 minutes, so yeah.
Dang, wrong answer. Okay. What should we do? Probably just solve it. Yeah, why wrong?
So I don't spend all of my time here. I do try another wrong answer that's like picking continuous ranges, but it's just not right.
If we don't get it, we got to move on, though. This is too... Yeah, let's move on. You have an array A of size n consisting of zeros and ones. You do the following operation. Choose two indices, add AI to AJ, remove AI from A. So you pick two indices, you increment the other thing, and then you remove this. Okay. What's the minimum operation to make A non-decreasing? So you want to sort it. So you delete ones and add zeros, right?
Omniscient David says yes.
Yeah, you might as well delete a 1 every time. So it's like I mean the middle. Int n equals this, int array A, read array size n. Then we need the 2 pointers, and then we need to meet in the middle, right? How do you do that? We got the 2 pointers. Increment left until we are at a 1. Decrement R until we are at a 0. Swap if needed. Okay, so then while L is less than N and A at L equals 0, L plus plus, while R is greater than or equal to 0, and A at R equals 1, R minus minus, if L is less than R, int n ops equals 0, and ops plus plus, and then L plus plus R minus minus. Out dot print line and ops.
So that's what my real-time implementation speed looks like. Sorry for putting you through that, but I felt it would be useful to keep one of them in there. Turns out it's right. Submit it and then move on to C.
Okay, this one we got. Surely. Surely. All right, let's move on to C. Permutation operations. You're given a permutation A of size n. You should perform n operations on it. In the ith operation, you can choose a non-empty suffix of A and increase all of its elements by I. How can we perform the operation to minimize the number of inversions in the final array? Okay, we have a permutation. We can choose some suffix and increase its elements by I. A permutation? Minimize the number of inversions. Surely you can make 0 inversions.
So I kind of misunderstood what I read here. The problem clearly says increment the suffix by I, but I just internalized increment by 1. And apparently this was like a common way of misreading it. Like there were people in Codeforces who said the same thing.
Oh, increase all of its elements by I. Oh, maybe it is possible then. Yeah, then it is possible. So do we have to print the array at the end? Output the starting index. Okay. Yeah, so we'll have int n equals this. Then a priority q integer. PQ, new priority q. And then an array. Read array size n. And then for int I equals. Oh, wait a minute. Does this work? We need each thing minus the max, don't we? Each index minus max in front. Okay, so yeah, so we need, and then int max scene equals A at 0. So we need the max scene before us, so max scene equals math.max of max scene or I, and then if I is less than max scene, pq.add. What do we add? Max scene minus I. Yeah. Okay. So then 4 int I equals 1. I is less than n plus plus. Less than or equal to n. If pq dot is empty, then out dot print 1 plus a space. Else int index equals pq dot remove. This isn't an index, this is a value. Dang it. So these need to be more complicated. All right. Can we just store this as... No, we need a pair. Dang it. That's why I use C++.
So in case my ramblings weren't clear, what I'm doing here is I look at the difference between each element and the biggest element in front of it. And every step, since over time, the amount that you're adding to the suffix gets bigger and bigger, you want to add to like the least needy suffixes first. And that's what I'm doing. Now this works, but there's a better way of doing it, or at least an easier to prove way, which is you can just make everything add up to n plus 1. So you match the 1 with the n, the 2 with the n minus 1, the 3 with the n minus 2, and so on. And then at the end, your array is just all n plus 1s, and clearly that has no inversions, right? So I didn't see that in contest, but I thought it was really clever afterwards.
And then we should be good, and then out.println. Does that work? Let's see. 1, 2, 3, 4. I think 5 at index 0. try again. This looks fine. This looks fine. What's this one? So index 3. Okay, yeah. This is index 3 plus 1, index 3 again, and then we should be good. All right. Yeah, I think that's fine. Okay. So submit C. Oh, did they say if they're more than one answer, more than answer print any? Okay. Okay. All right. Standings, front standings. All right, we're doing terribly, but that's fine. Let's move on, I guess, to D. You have a rooted tree of n vertices. The vertices are numbered from 1 to n, and the root is vertex 1. You can also... we should probably make sure we got this problem first. We did. Okay. Oh, dang, this is... Oof. Okay. All right, maybe we solved A then. Let's read it. We have a rooted tree of n vertices numbered 1 to n. The root is vertex 1. You're also given the score array S1 to Sn. A multiset K... A multiset of k simple paths is called valid if the following two conditions are true. The path starts at length 1. Let Ci be the number of paths covering vertex I. The number of paths covering vertex I. Okay, wait, so we have a tree, we have a rooted tree, and a score array. Okay, so it's valid if the following are true. Each path starts at 1, so we have like a try basically. All right, and then Ci is the number of paths covering vertex I. It's hot. Oh my goodness, it's hot. This was before the contest started. It's like 20 minutes ago. Ugh. Been just sitting there for 20 minutes, still burning hot. All right. So, like insulative things are just the worst. Ugh, so hard to predict. Okay. For every pair of paths that have the same parent, they're covered almost the same number of times. All right. The value of a multiset is like the sum of, so every time you have a path, it's just you add that to your total. It can be shown that it's always possible to find at least one valid multiset. Find the maximum value among all valid multisets. Doesn't seem that hard. If we have, yeah, this doesn't seem bad. I guess it seems about as difficult as a problem D would be. Yeah, it's a little annoying. Let's solve A. These samples are trash.
So that's an immediate red flag, by the way. Anytime you're given trash samples, often that means that the problem is really simple, and if they gave you complicated samples, it would give it away. Which is true here. In just a minute, I figure out exactly what the issue is, knowing that this is a concern. And the issue is, I wasn't ever considering doing the pair deletions first. I was only doing the pair deletions at the end, and what I was trying. So yeah, you'll see me figure this out in just a sec here.
Oh, I'm an idiot. God dang it. I'm so stupid. All right, moving on from that. I didn't even think you could use the first operation before the second. Oh, I'm dumb. All right. Oh my goodness. It took so much time. Hardest problem of the set, I'm telling you. Okay. How are we doing? Minus 176. We can do better, I'd say. Let's get E, or let's get D. So we need to distribute things to our kids, and we need to know which one's better.
The idea here actually isn't that complicated. It's a pretty normal DFS, but I think it does a great job of testing whether you actually understand how DFSs work. The idea is basically you distribute the paths among your children equally, and then you need to see which of your children are best for the last path that you might give them, and you sort them by that and then give it to the best prefix of them, depending on how many you have left.
All right, node.push, and then I think we're good. Let's try it.
54, 56. Seems legit. Submit D. Oh, we might need DFS or like stack trick. Okay, we're probably good. All right, moving up a little bit. Minus 25, that's fine. Ooh, look at this. All right, here's where we look at the score distribution. So 2,000, 2,500, and 3,500. How are the best people doing? Interesting. All right, so we read at least these three now. Determine what to spend our time on. Nope, we want that. We don't want any of these. Okay, E1, E2, and F. Okay. The only difference between this problem and the hard version is the maximum number of queries. All right, we got 82 or 53. Okay. What are we trying to do with these queries? There's a hidden integer x, which we have to find. All right. In each question, you can choose a non-empty integer set x and ask if x belongs to s or not. After each question, if x belongs to s, you'll receive yes, otherwise no. Sounds impossible. So what's the thing? But the problem is, wait. Oh, wait. Sounds okay. It sounds really easy actually, because these can be arbitrarily big. All right. The problem is not all answers are necessarily true. Some may be joking. It is just guaranteed that for each 2 consecutive questions, at least one of them is correct. Additionally, to the questions, you can make at most 2 guesses for the answer X. What does that mean? So basically, you get to pick 82 sets of numbers. And after you pick a set, the judge will tell you whether or not the answer is in that set. But the judge can lie. The only constraint is the judge can't lie twice in a row. So the way it works is you can sometimes eliminate something. If twice in a row the judge tells you it's not in this group or it is in this group, that means the judge is telling the truth. So that's how you can actually eliminate things. And you need to bring the size of your set down from the 100,000 elements initially to 2 possible elements. Oh, you can guess twice. Oh my goodness. Interesting. I have an immediate idea, which is just do things in base 3, right? Oh, does that work? No, it doesn't. So we'll save you the pain of watching this. Turns out that I go through some pretty complicated ideas, and it takes me way longer than it should to implement this. There are some observations that make it a little bit easier, but overall it's just like, I coded it in a messy way, and it was pretty unnecessary. Before doing this, I spent like maybe 10 minutes on F, but this is pretty much just the rest of my contest. And I finish it like a couple minutes after it ends. All right, so it's been the rest of the weekend, and I have done some upsolving. In the contest, I got A, B, C, and D. Right after contest, I got E1, and then I got some Qdoba, took a break, because I was a little tilted by that performance. And I figured like my solutions wouldn't be too helpful, so I thought we would make a more entertaining video out of this instead. And then I've upsolved E2 and F as well. So these are all the problems that Tourist solved in contest. He won the round. So all the problems he got that I didn't, I have now solved. F was really not that bad. I definitely could have gotten it. If the set did not contain problem E, I would have solved problem F. I'm confident. I got it in like an hour after contest, and it used an idea. It's pretty quick to type too. It used an idea I'd seen before. I won't spoil it here. Maybe I'll make a separate video just on that problem because I liked it so much. But yeah, problem F, it was good. I thought it was a solid problem. And then problem E2 was actually pretty tough. I had to look at part of the editorial for some of it because I didn't quite think of all of the pieces you need. But it's a good problem, which is a running theme throughout this contest. I gotta say, all of these problems were just grade A quality. It doesn't get better than this. This is like, everything that I saw about them was fantastic. I would be very proud of this round if I had written it. Obviously, I didn't. I was doing Hacker Cup stuff. But I think it's really good. And I'm a little disappointed, frankly, in all of you guys for not giving these people 1 million upvotes. What is with the 214 contribution? Why is this so low? Yeah, people, it's a great contest. Come upvote them. Their editorial was a little slow, but everything else, it was great. They did a great job. Give them some contribution, please. Please, please. They're giving you t-shirts and everything. My goodness. And by the way, there is no bias there. I tanked this round. I lost a whole bunch of rating. I'm now at 2,444. Ugh. So, yeah, these people, they deserve some contribution. They just do. They do. Anyway, there's that. Let's do a quick round recap. I think maybe the biggest thing worth talking about is that problem A took me 33 minutes. 33 minutes to check if an array is all zeros. That is unacceptable. So I got to improve there. I think that's probably the biggest thing that needs to be fixed. And it's kind of hard after you don't get A for half an hour to have this be like the best performance that you've ever had. Problem A with this is that problem A is not there. You don't have it. You don't have the points for 33 minutes. So just straight up, you're going to get mass. And if you don't get something for 33 minutes, you're getting the wrong answer. So you lose points there too. So yeah, at the end of the day, you just don't have a good score on penalty for your problems if you're not getting problem A for 33 minutes in. The other thing here is that mentally, there's a lot of like doubt that goes in. There's just a big question mark. And like, what is your round strategy when you don't have problem A? Most of the time, 5 minutes into contest, problem A is not even, you don't even think about it. For the rest of the 2 hours and 10 minutes in front of you, you can just ignore it. But when you don't have it, there's the lurking thing in your mind. It's like, well, should I consider problem E? Should I go back to A? Should I solve D? What should you do? So yeah, and it just like makes you less focused, and it's negative impact. That's all I can say. So that's that's one way to improve. Figure out how to do problem A. Yeah, but I don't know. It's not all that. The big thing was I didn't get E1, right? E1 I could have gotten. I was a couple minutes away from getting it, and I think part of that was just me getting a little unlucky with the paths that I tried. But another big part of it was I started typing too fast. Like, I started doing this, like, split it into 4 groups, eliminate one strategy, which works, and that's the strategy I first AC'd with, but you don't need to do it at all because you're going to need a strategy to have 3 groups and get rid of one of the groups. Because you're going to end up with 3 things, right? If you eliminate a 4th every time, you're going to end up with 3. How do you get it down to 2? You need a strategy that takes 3 and eliminates 1. And if you have that strategy, I don't know, you might as well use it elsewhere, right? You might as well just only use that strategy. It's good enough. So, yeah, I could have saved a decent amount of code there. And then also, it was just slow. Like, I could have done it faster. That's what to improve for next time. But ultimately, other than, like, be smarter, how am I going to get better? What am I going to do? And, there are 2 ways to get really good. One is be a genius, and the other is work hard. And as we've seen today, I am no genius. So upsolving is a start, and the rest is making sure I've got the tools I need, making sure I can implement really quickly, and making sure that as soon as I have a solution in my head, I can get it on terminal and submitted as fast as I can. And then there's the become closer to a genius part, which I guess I'll be working on for a while. All right, enough rambling from me. Let me know if you want a video on problem F. I thought it was really cool. And have a great day. I'll see ya. Goodbye.